Hello everyone, and welcome to Lesson 10. In this lesson, we're going to do several practice problems together. All we are doing is expanding on what we've done so far. We're looking at different styles of problems. Some are similar in some ways, some are similar in other ways, some are unfamiliar. But we're going to be looking at these problems, 3 of them in this session, and we're going to be repeating what we've done before next week moving on to a new section. So essentially we're going to look at 3 problems, and we're going to look at the natural language problems, and then we're going to, from the natural language problems, we're going to again end up in a situation where we've converted those natural language problems into the mathematical models that we require to solve in order to determine the optimal choices for those specific problems. So let's begin. The first problem we're going to look at is a problem involving dietary requirements. This is a relatively common situation. It's a relatively common question type. In this question type, we look at different ideas and we look at different dietary options. And from those options, we choose the optimal choice that will give us the nutrients we require, generally while minimizing cost. So, as always, let's begin by reviewing the question carefully. Practice problem 5. A doctor tells a sick freshman to add bananas and oranges to his diet for vitamin A, vitamin B, and vitamin C. A pound of bananas contributes 8 grams of vitamin A, 6 grams of vitamin B, and 2 grams of vitamin C. A pound of oranges contributes 2 grams of vitamin A and 6 grams of vitamin B. A pound of bananas costs $3.50, and a pound of oranges costs $5.40. The student has to meet a minimum requirement of 23 grams of vitamin A, 37 grams of vitamin B, and 6 grams of vitamin C. He should also avoid taking more than 50 grams of vitamin A and 70 grams of vitamin B to avoid side effects like nausea. What is the ideal mix of fruit for the sick freshman? So as always, we begin by overviewing the question and choosing the key components. So a doctor tells a sick freshman to add bananas and vitamins to his diet. We'll click this part as well. This is our first key requirement. We want to add both bananas and oranges to the diet because, and again, key information, we require vitamin A, vitamin B, and vitamin C. A pound of bananas contributes 8 grams of vitamin A. So we know bananas is 8 grams of vitamin A, 6 grams of vitamin B, and 2 grams of vitamin C. A pound of oranges contributes 2 grams of vitamin A and 6 grams of vitamin B. Another key point. A pound of bananas costs $3.50, and a pound of oranges costs $5.40. Again, key information. The student has to meet a minimum requirement. Anytime we see minimum requirement, we know automatically that this is going to be a limitation. So we have a minimum requirement of 23 grams of vitamin A, 37 grams of vitamin B, and 6 grams of vitamin C. But we also have 2 more. We should be taking no more than 50 grams of vitamin A and 70 grams of vitamin B. What is the ideal mix for the sick freshman? So what we've found here is all of the key information contained in the question, And what we require now is to reorganize this information into a meaningful format. So the first step, the first thing we have to do, as always, is determine what is being decided. And we see that here in the last sentence. What is the ideal mix of fruit for the sick freshman? So our decision variables become x1, bananas, and x2, oranges. We have both the bananas and that's the number of bananas to include in the diet, and oranges, and that's the number of oranges to include in the diet. So we have x1 and x2, number of bananas, number of oranges. Now we have to look back here and we have to relate our decisions to our ultimate goal. So in this situation, we know our decision is bananas and oranges. However, our ultimate goal is not directly stated. When we are adding something to our diet or we are purchasing extra amounts, in this situation, we have a scenario where we want to add, but we're spending money when we add. So to spend money when we add, we're in a scenario where we want to minimize the amount of spending. Okay, everyone, sorry about, I just took a quick, we had a quick situation. What we're going to do now is we've outlined some of the issues, but now we have to get into the objective function. And one way, we just looked at our decision variables. A good way to determine your decision variables, if you're a little bit unclear, is typically looking for the dollar values associated with an item. If bananas cost $3.50 and oranges cost $5.40, we generally have an idea that these will be our decision variables. How much of each should we be buying in this situation? So let's go ahead and do our objective function now. We see here we're going to minimize z as we discussed because we're trying to minimize our cost. And that's equal to 3.50 x1, 350 per orange, plus 5.40 x2. And that's $5.40 per banana. So what we've done is we've related our ultimate goal of minimizing cost with our decisions, which is x1 and x2. That's the basic idea governing an objective function. How can we relate our ultimate goal to the decisions we're making? In this situation, how can we minimize cost when deciding how many oranges and how many bananas to buy? So moving on to our second section, we look at constraints. And our first one, we come in and we see that we're going to have requirements of vitamin A, requirements of vitamin B, and requirements of vitamin C. Those become our first three constraints. C1, C2, C3. So C1, we have a situation where it is the amount of vitamin A available. So we'll just put that here because we're not sure about the parameters or the numbers guiding it yet. So that's minimum amount of vitamin A. And we know that from our question. We also know there's a minimum amount of vitamin B. We haven't done it like this before, but this is a viable way to do constraints as well. So we're just doing it as an alternative in case you do get stuck. So minimum amount of vitamin C. Then we have C4. And we come back and we have maximum amounts as well. Maximum amount of vitamin A and maximum amount of vitamin B. So we'll come in one more time and we'll revisit that. Vitamin A. And this is, as I said, an alternative way to look at things, but equally as effective if it helps you find the correct constraints. So now we're going to go into our parameters and we're going to check what are the maximum and minimums. A pound of bananas, we see here there's a minimum requirement of 23 grams of vitamin A. So we come here and we have 23 grams. We go back and we see there's at 37 grams of vitamin B is our minimum. So 37. And then we go one more time and we see our minimum amount of vitamin C is 6 grams. We also know our maximum. When we come here, our maximum is 50 grams of vitamin A. And our maximum, one more time, is 70 grams of vitamin B. So all of these situations now, as we have our maximums, but we have to know how much we're contributing per apple and or per banana and per orange. So we come back here and we see bananas is 8A, 6B, 2C. So bananas is X2. Bananas is X2. So we come over here and we go, bananas is X1. And so we see from here it's 8, 6, and 2. So 8 X1 plus 6 X1 plus 2 X1 plus. And we're going to come in and we're going to check our banana situation, our oranges. Oranges is 2A, 6B, no C. So we come in here and we go 2 and again, just double checking, we see that it is 6 grams of vitamin B. So we have 6x2 greater than or equal to 37. And here we have no vitamin or nothing from oranges, so 2x1 must be greater than or equal to 6. So we've completed our first 3 constraints. Now we come over here and we see C4 is 50. But we know this is vitamin A. So anything vitamin A, this is our contribution right here. So we control C, control V, and it must be greater than or equal to 50. Because this is how much vitamin A we're getting. It must be more than 23. But how much vitamin A we are getting must also be less than or equal to 50. More than 23, less than 50. We repeat that one more time here. And it's less than or equal to 70. So following this new pattern, and again, both work equally well, the key is being able to look at everything and put that information together by yourselves. So we've got in this situation, we have practice problem number 5. I'm going to leave you now with this because I have 2 more problems for you to solve on your own. This was another example, but before we do that, we're going to collect everything in our standard format. So we come down here, and we're trying to min z equals 3.5x1 plus 5.4x2. Subject to our 5 constraints. The first one, 8x1 plus 2x2 greater than or equal to 23. One more time, 6x1 plus, let me just double check, 6x2, and that's greater than or equal to 37. So then we come here, we do our third one, and that's only 2x1 must be greater than or equal to 6. Those are constraints 1, 2, 3. Then we have the 2 maximum amounts. So 8x1 plus 2x2 must be less than or equal to 50 units. We do the same thing here. 6x1 plus 6x2 must be less than or equal to 70 units. So once we've formatted our final problem, we've taken our natural language problem, we've converted it to our standard formula, our standard format, and we are ready to proceed in problem solving. This is another example of how to proceed. That is the conclusion of today's video. I'm going to leave you with 2 homework problems for the quiz, the participation quiz today. You have this plus the 2 homework problems you are responsible for. All 3 of them will be on the attendance quiz. Thank you everyone for listening. We will continue in lesson 11 with a similar situation to what we did today. Thank you again for listening. If you have any questions, as always, please contact me and I will answer your questions to the best of my ability. Thank you again.